Sorry for the slight delay. So now Professor Basaki is going to start his lecture.
Okay, very good noon to all the students and other dignitaries present here in this auditorium. But before I begin, the last documentary that we have seen, The Inconvenient Truth, has really put me into a lot of inconvenience, because after such beautiful exposition of the danger that civilization is facing, I think it is now very hard to impress upon with other topics. But anyway, I will try my best, because see, there are always this constant tussle going on in the world. One set of people wants to build things, and there are other people who want to destroy, possibly knowingly and sometimes unknowingly. And today, what I am going to describe is the efforts of people who have changed the lives of millions of people through their untiring efforts. But it actually dates about more than 100 years back. At the outset also, I should thank, before I forget, let me thank Professor Das and Professor Tapan Pine, as well as his team members, for giving me the opportunity to interact, to present on this occasion. It's a great day in Indian science. You all know, I don't have to repeat it, but this is the day when the first Raman effect was observed. But Science Day is not only about Raman, at least to me, it is beyond the Raman effect. We should also salute at the scientists who have taken us up to this point. And during that era, during Raman era, there are other scientists who have made significant contribution and also noted and acknowledged throughout the world. So I thought that along with Raman, I should pay respect to those souls on this day also. So Jagadish Chandra Bose, then Prafulla Chandra Rai, Satyendranath Bose, Prashant Chandra Maulana Bose, Raman himself, Meghnad Saha. These are the pioneers. They are the builders of science in India. And since I am a chemist, Prafulla Chandra Rai is the one who started the research in chemistry in India. Now today my topic talk is feeling the excitement through molecules. As a chemist, we always want to see that if something is there, some substance somebody brings in, we want to know the structure, what it is. Okay. And about 2-3 years back, I had this book written by Professor K.C. Nicolau. He was at the Scripps Research Institute at that time. And he wrote a book, that Molecules That Change the World. We know that there are several things that change the world, like world wars, like different phenomena which have changed the world. But this struck me immediately that yes, there are certain molecules which make the lives of the human beings so smooth, easier, and the longevity has gone up. So he talked about several molecules in his book, which are all given here. And it started with very small molecules like urea and acetic acid, and slowly went into more and more complicated systems. Some of them are really, they have complicated structure, but each one, after their discovery and after their biochemistry as well as the chemistry, their structure, they feel that yes, these are certainly turning points that we call turning points in science. Particularly, this book was written with an aim to focus on the medical aspect, on the medicinal aspect of these molecules. So most of the molecules that I will be talking about today, I have picked up some of the molecules from this list and added few more according to my concept. And then I will show you what is the development, who developed those molecules, and what is the excitement about those molecules, why they are so special And why do we say that they have changed the world today? Urea, you know, was important for organic chemistry point of view. This was the first time when somebody showed that urea can be obtained from an inorganic molecule. That famous Bowler's experiment. But without urea, the whole agricultural chemistry would have been the kind of sustenance that we have. Urea was a turning point. The discovery of urea as a fertilizer was definitely a turning point. Then, this is a very small molecule. Another small molecule, aspirin. This is very well known. This is now there in the market for more than 100 years, and perhaps one of the very few drugs which stood the test of time for more than 100 years. And more attributes are being associated, attached to this molecule. That means it is showing newer and newer properties, medicinal properties. These are the ball and stick structure, just to make it attractive. So these are small molecules. I am showing the structure. And then came the discovery of the paracetamol, which all people we take every time. Whenever we get fever, that is the other name is acetaminophen, and this is the ball and stick model. You have the penicillin G structure here, and that is the antibiotic. You have ciprofloxacin, that is an antibiotic, and then you have Rontosil, that is one of the first antibacterial agent. In fact, that is the second antibacterial agent which came into the market. I will go or describe some of these in my lecture. These are the physical characteristics of these molecules. And one of these you see that the Rontosil one is bright red powder. Okay. And there is a reason that why it was red, because the scientists were very fascinated. The scientist who discovered it was very fascinated with color and bacteria, how they actually behave with each other. That means if you put color on the bacteria and then wash away the bacteria, retains the color of the and then finally out of that the scientists who discovered that actually it was a kind of cyclic arsenic compound. Now this is the story of first magic bullet. Louis Pasteur's germ theory, as I said, that set the whole ball rolling. And then Koch discovered the germs for TB and anthrax. And then in between there was somebody else. I forgot to mention his name. His name was, this is Robert Koch. He discovered the TB germ in one body. He developed Oxford to isolate antitoxins for diphtheria, and that was used to treat the diphtheria. So before any other diseases were cured, first the vaccine was already known. It was by Jenner who did the pox vaccine, but this diphtheria vaccine was developed by Boyle. And then Paul Ehrlich, as I said, he was a member of Koch's group. Now he set up his own research team to build his own lab. And you see that he was a person, even at this age, he was working in the lab, holding a test tube and checking which compound is being made. Ehrlich knew, as I said, certain dyes stain the bacteria, the species. And he also knew that certain chemicals, like the antitoxins, they have the ability to kill bacteria. So he combined these two concepts, the dye and the killing property of other compounds, into his magic bullet concept. I told already. And I think, let's see, we should move. Yes, this is when syphilis, when somebody suffers from syphilis, that's what happens to the skin. You see like skin burns, and there was no cure in those days. A lot of people were dying. And this salvarsan, the compound 606, that he was holding it, that came as a miracle, and it saved millions and millions of persons. And as I said, apart from that, the most important is that he is the first person to show that the chemotherapy, by chemotherapy you can cure a disease. Okay. I think we can stop this. Ehrlich and another person, Doman, who had discovered Prontosil, the first antibacterial agent. We had in our own country, Sir Bendranath Brahmachari. He was trying to develop a drug for a disease which was known as black fever or kalazar. Again, this became an epidemic. A lot of people, particularly in eastern India, were suffering from this devastating disease. Instead of arsenic, which Ehrlich used, he used the antimony, but it's the same series. So arsenic followed by antimony. So he used an antimony amino acid. It's an antimony-based acid, para-amino-phenyl stevaic acid actually. Antimony, the name is Sp is stevine. Okay. So this stevic acid with a handle, which is urea handle. So he called this molecule as urea stevamine, and that proved to be a very good therapy for the drug for eradicating the kalazar. And in fact, in 1930, C.P. Raman got the Nobel Prize, and interesting to note that Brahmachari was a nominee for the Nobel Prize in 1929, but unfortunately, for some reason, this discovery was not considered by the Nobel Committee to be fit for the Nobel Prize. But anyway, we think this is one of the pioneering discovery which is a little overlooked in between Paul Ehrlich and Doman. So next came, after Brahmachari, it was the third of Paul Doman. Bernard Doman. And he received Nobel Prize in 1939. Doman's discovery also was kind of little bit overshadowed because during this period, the development of the first antibiotic, penicillin, was going on. That whole history took place between 28 to 41. And in between, Doman discovered his drug, what is called Prontosil. And this is again, you see, an azo-based compound. So azo-based compound must be having something in them which makes them an antibacterial agent. Now there is a difference between antibacterial agent, sometimes I am talking about antibacterial, sometimes talking antibiotic. Antibiotic, any molecule which kills bacteria is an antibacterial agent, but if the molecules are derived from the biotic systems, that means from living organisms, they will call them as antibiotic. So Prontosil actually is an antibacterial agent. It was made synthetically by chemists like Doman. Okay. Prontosil is called the second magic bullet. The first magic bullet was Salvarsan by Ehrlich, and Prontosil is regarded as the second magic bullet. And the third magic bullet is basically, nobody has called it, is possibly the penicillin. I will come to that, the penicillin discovery. Doman discovered that a particular red dye was effective against some cases of blood poisoning. That means he was making a lot of azo dyes which are used for dyeing the clothes. He was literally using those cloth dyeing materials to see what is the effect on the bacteria. And he called the drug Prontosil. I think this is the picture where he is working in the lab, and then what happened? He developed Prontosil. The development has some stages. First you have to check it in animals. So he was checking it in rabbits, and he found that the rabbits are cured by this Prontosil, but he never tested it on the human being. But what happened on a particular day when his own daughter, a small daughter he had, and she got infected by a needle. By just a needle where you do this wool and needle, so that needle got into her arm, and then that got infected. And she was almost dying, the blood became infected. And then he didn't have any other option but to inject the Prontosil. At that time it was not tested on the human. So the first human was that he tested on his own daughter, and his daughter, I think this is there, Doman's daughter, height guard, pricked her finger on a needle and she was given and she survived. So that was the, so people say that this is an accidental discovery. Now all discoveries, some or not all, many of these discoveries are by accident, but this accident escapes the eye of many of us, but it does not escape the eye of a great person. So because Roma was a great person, they could feel the importance of these events. Okay, I think then sulfonamide, there was one important fellow who was also saved. Along with Roman's daughter, another important person whose son was also saved by Torontosil, and that was none other than Roosevelt's son. So during that World War time, Roosevelt was the president of USA, and his son was also suffering from, this is there, the patient's name was Franklin Roosevelt's son. He was also cured by Torontosil. This is the film. So these are some interesting stories about Torontosil. Now in between, when Torontosil was discovered, there was also a turning moment that was about to happen in the history of in medicine, and that was also in 1928. See, 1928, C.V. Raman saw the Raman effect. 1929, our brahmacharis narrowly missed the Nobel Prize. 1930, C.V. Raman got the Nobel Prize. 1928 is also special because in that year, Sir Alexander Fleming, who is the pioneer for discovery of penicillin, he also observed that the fungus Penicillium notata has the ability to elicit a compound which he called penicillin, and that has the ability to kill the bacteria. So how did it happen? And what exactly happened? Who really discovered this molecule penicillin? That is during my few slides. This is Fleming working in the, this is also a book in that, a chapter in that book, which is the molecules that change. Oops. So this is Fleming at the old age. I think these are all reconstructed. Later on, people took the picture when he became really famous. And this is the chapter 13 of that book by Nicola, which has got a, which it describes what really happened in the history of penicillin discovery. After some of these pictures, I will go through the documentary, because there is a documentary on this. And this is the famous slide. See, when you do a bacterial assay, antibacterial assay, what you do, you take a dish where you try to grow the bacteria, and if you want to see whether there is any effect the other compounds have, you add the compound also during the growth. And if you see that the whole plate has become hazy, then that means the bacteria has grown. The compound that you have added does not have any activity. So, but if you see any clear zone inside, that means your compound is having an antibacterial activity. So what Fleming observed, this is the famous plate which is there in the St. Mary's Hospital, that Fleming saw that this is the fungus, and alongside in the circle, near vicinity of the fungus, the bacteria, in a clear zone, bacteria didn't grow. And from that, he concluded that this fungi must be eliciting a compound which is antibacterial, which has got antibacterial activity. Now, but Fleming was a microbiologist, and although he knew that something is coming out of this fungus, he knew the origin of the fungus because he was working on the first floor of St. Mary's Hospital, and in the down floor there was another fellow who was working on Penicillium notata. So that fungus actually came out from the window of the bottom floor, went up and came to Fleming's room. And Fleming was very special because he was not a very scrupulous kind of scientist. Some people are very organized, very clean and thorough. Fleming was little bit untidy in his approach. In his autobiography that was also written. But because of this